Every year, over 100 billion aluminum cans are produced. It's one of the most cherished metals worldwide. It bends like paper and endures like steel. It's used for preserving food and beverages. But how are millions of aluminum cans made? In this video, we'll delve into how Coca-Cola cans are made, from recycling into massive aluminum rolls to filling the cans. Every week, the world consumes an astounding 4 billion cans of fizzy drinks. Although it's now nearly everywhere, aluminum was utterly groundbreaking when first utilized in the 1890s. 150 years ago, it was pricier than gold. Carbonated drinks weren't much sold in aluminum cans until the 1960s. But since then, cans became so popular that Americans use over 100 billion aluminum cans every year. About 45 billion cans are recycled in the United States annually, and over 90% of this amount is converted into aluminum ingots used for manufacturing new beverage cans. This is the world's largest enterprise for recycling used beverage cans. They arrive from all over the world at their factory in England, compressed into bales weighing up to 2,200 pounds each, containing up to 65 million aluminum cans. The aluminum can packer aids in crushing and compressing loose cans into dense blocks of uniform size. The machine also wraps the solid blocks with sturdy, thin wires. This keeps the cans intact and makes them manageable and much easier to stack, load, and relocate. The compressed can blocks are loaded onto a conveyor belt and fed into a 340 horsepower shredder. Aluminum is challenging to classify because, unlike other metals, it can't be separated with a magnet. So, the shredded bits pass through an optical sorter at a speed of 9 feet per second. The machine employs infrared sensors to classify what's metal and what's not. Aluminum contains contaminants like paint and lacquer. The clean aluminum bits are ready for the next phase. 2 furnaces reach scorching 1,300 degrees Fahrenheit and handle up to 100 tons of metal each. When aluminum melts, it reacts with the air, forming a layer of aluminum oxide that floats above. This unwanted oxide is slag, and a worker removes it with a giant steel spatula. A river of molten metal flows downhill to a retention furnace, the size of a 2-story bus. Somehow, they need to pour the liquid metal into a mold. Inside, they'll be cast into 3 imposing aluminum blocks. Layer by layer, hot metal is added and rapidly cooled with water. As it solidifies and becomes denser, it sinks further into the mold, allowing more aluminum to flow over it. After 2 hours, they have 3 giant aluminum ingots. Each one measures 30 feet long, weighs 27 tons, and is made from 1.5 million recycled cans. Today, the demand for aluminum is so high that the ingots don't just sit idle. Their transformation back into cans begins with a 560 miles journey to a rolling mill. They're heated in another furnace to 970 degrees Fahrenheit. This relaxes the bonds between atoms, releasing any tension within the ingot. Then, they're passed back and forth through a series of rollers. It's like stretching pizza dough. Each set of rollers reduces the metal until it's a 0.01 inches thick and 6 miles long. With this, enormous aluminum rolls are formed and sent to Coca-Cola can factories. Coca-Cola's can supplier is a global beverage container producer. In this factory, containers are made, primarily for Coca-Cola beverages. They can make up to 2,000 cans per minute. The cans start as enormous aluminum rolls weighing 20,000 pounds. Each roll will yield about 700,000 cans. The process for making the cans is highly automated. Once the holes are punched, they're spread into sheets. The aluminum sheets are fed into a high-speed draw press. This punch press presses the metal over 200 times per minute, creating the can bodies. Each time this press is activated, 14 can bodies are created. The press punches out a 5 inches diameter disc and then proceeds to fold it into a cup shape. Anything left over is compacted and sent back to the aluminum factory, where it will be recycled into new aluminum sheets. A forklift carries them to a sort of resting area, from where they're distributed to the next machine. In that machine, the can bodies are formed. Inside it, a bar pushes the can bodies through a series of increasingly smaller molds. Forming the can body requires a lot of lubricant. For the can bodies to pass through these molds, it's vital that the machine is properly lubricated. Otherwise, the aluminum could break when stretched. This lubricant also acts as a coolant to prevent overheating. That's why the cans come out with so much grease residue. Once the body is formed, a machine will clean and straighten the edges properly. After this, a conveyor will carry the cans upside down to the washer, where they'll undergo a cleaning divided into 6 stages. The cans enter the washing area to remove the oil from them. One washing stage includes sulfuric acid. The cans are sprayed with a jet of ionized air. When the washing is finished, they're ultra clean and ready for filling. Each completed can weigh less than half an ounce. Each and every one of them is a pressure vessel. They must withstand almost 3 times the pressure of a car tire. The cans are now ready for stamping. This rotary printing system can apply up to 5 colors. Stamping the Coca-Cola logo on the cans starts with a kind of rubber mat rolled onto a cylinder. This cylinder is then installed in a machine called a decorator, a giant printer for cans. The main color that runs through this decorator is red, but these cans aren't decorated with just any shade of red. It has to be Coca-Cola red. Then, the machine sprays a varnish on the inside of the cans. This creates a barrier between the beverage and the aluminum, so the product doesn't end up tasting like metal. And it also prevents the acid in carbonated beverages from corroding the aluminum from the inside. The cans then go to a machine that forms a 2-inch neck. The necker forms a curved edge at the top where the lid piece will join. Now, what they need is the top lid. This process takes place inside this machine at a speed of over 2,000 cans per minute. Defective cans are detected immediately and sent for recycling. The finished cans won't spend much time in the warehouse. Many of them will be transported to the bottler, where they'll begin their quick journey to the filling area. Subsequently, the cans enter the filling machine. A high-pressure carbonation machine introduces gas into the non-carbonated syrup. The soda cans are cooled to 40 degrees Fahrenheit to prevent the presence of carbon dioxide from escaping the can. The machine's valves can fill 130 cans at a time at a speed of 1,700 cans per minute. A single worker supervises the entire filling process. They have an essential task, ensuring that the machine placing the lids doesn't run out of lids at any moment. Inside this machine, the lids are embedded into the cans. The factory has to ensure that their customers receive a fully sealed can. They use a scanner with gamma rays. Cans that haven't been properly sealed are separated and recycled. At this point, the cans are at an ideal temperature for consumption. Inside a box, cold cans could condense and wet the cardboard. So, they're sprayed with water at 95 degrees Fahrenheit to reach a suitable temperature. After 12 minutes under hot water, the cans lose their chilly temperature. When they come out, they're at around 80 degrees Fahrenheit. Next, the cans need to be dried with air. Some cans end up in packs of 6 units joined by a plastic ring. Others end up in cardboard boxes. These cans will be part of a 12-unit pack. In a year, a can can be recycled and sold up to 8 times. If you enjoyed the video, you can watch similar videos clicking them on screen. Also, subscribe to this channel by enabling notifications to keep learning.